All right, let's get started. If you hear bells in the background, I apologize for that. I don't know what's going on, but there's a lot of bells going on. Okay, but welcome everyone to our networking, our networking talk for Swift. Can you go to the next slide? Yeah, so first there's some announcements. So once again, I am asking you to become a paid member. We have really cool stuff such as t-shirts, stickers. We're going to be doing paid member raffles and giveaways. So if you become a paid member, then you will qualify for those. We also are reaching out to industry professionals to bring our mentorship program. This is going to be a one-on-one mentorship program where you can get lots of feedback, lots of advice from industry professionals who have been working for years and are very experienced in the field. We're also working on certification reimbursement in case you want to get some certs and get some money back, as well as our red versus blue that we're pushing out to Swift in general, which is an adversarial and defensive simulation that we use to train for high schoolers, but we want to bring it for you guys. And there's a lot more with a membership perks as well. The link is https://da.gd 2122 member. It's $20 a semester or $35 a year. So if you haven't signed up already, please sign up right now because it's hell awesome. All right, with that being said, welcome to our networking talk where we're going to talk about all you need to know about networking. So it's going to be me, Robinson, and Jacob. So first, we're gonna talk about networking in general, and then go into some of the networking devices that we need to do networking. We're gonna talk a bit about the TCP/IP model, and then we're gonna go into addresses, ports, and protocols. And then after we talk about these things, we're gonna get into a little bit more of a demo where Jacob's going to talk about Cisco Packet Tracer, and I'm going to do a little bit demo of Wireshark and TCP dump, which are both packet sniffing tools, and we'll talk about that later. But previously on Swift Academy, we talked about virtual machines and a lot about Linux, thanks to Luis, Lawrence for the beams, and then Gabe and Justin for the Linux content. So with that being said, what the heck is networking? Networking is a pretty broad topic, but let's keep it broad and simple. So let's just think about networking as a set of computers sharing resources. So what you see on the screen right now is a networking diagram or a networking topology, and this is basically like a map of the network, a logical map of the network, I should say. And you can see, on like the left side, there's like a bunch of computers connected to those boxy thingies called switches. And the main thing is that they're all like interacting with each other. And the main reason why we call networking as like a way to share resources is think about this. You are one of the computers on the left and your buddy is also the separate computers on the left. If you want to collaborate on a specific file or a specific service, if you have separate files on locally stored on the machines, it's going to be very hard to try to collaborate. But if you put that resource somewhere on the network where everyone can reach and everyone can access, then that makes collaboration over the network easier. So once again, it's good to think about working as a way to share resources amongst computers or devices. Now, I hand it off to Robinson to talk about networking devices.
What the heck? Hold on. All right, sorry about that.
The back button, the left button.
All right, so I'm going to be talking about networking devices. The first thing we're going to talk about are like the main things you might see when you're talking about networking. So the first one is switch. So all a switch is it'll connect end user devices on a network. I'll go back to the diagram that Taylor was referring to give a little bit more detail. A firewall is basically just rules that you set that kind of allow inbound or outbound traffic to occur. A router is just connecting multiple networks together. A modem is you might think it's like similar to a router, but it's pretty different. All it does is translates a analog data connection to a digital connection. So that's how you get internet to work when you connect it to the router. And an access point is just it just broadcasts Wi-Fi to extend the Wi-Fi connection to other areas. So if we just go back real quick, this is a switch right here, and this switch is connecting all these devices on a local network, and the router, what the router is doing is connecting multiple networks. So for these devices to access these resources, these networks connect them all together to make networking work magically. Alrighty, so let's move on to some lingo. When you talk about networking, these are some of the definitions you should know. And I'll go back to the diagram to kind of describe it again because it's kind of complicated for definitions. So all these devices right here that you see on the topology, you can refer to them as nodes, and they're just basically networking devices on a topology, generally speaking. And an endpoint is these laptops right here, and they refer to points at the end of the topology. So these laptops, they're endpoints. This web server, endpoints, printer, this is an endpoint, and it's just basically where the networking topology stops, is where usually the user's device is. So that's what's a endpoint. And a gateway is kind of the routes that these devices use to connect to one another. So let's just say this laptop wants to access a web server right here. It will have to go to the default gateway, which most likely is your router. So it'll go through these routes and get to the web server. So gateways are just routes that devices take to connect with each other or to the internet. And an interface is basically a network communication point. So in each of these devices right here, they all have interfaces, and those interfaces allow you to communicate throughout the network or hit the internet in general. Alrighty, I'll hand it off back to Taylor to explain the TCP IP model.
Yeah, so before we start talking about the TCP IP model, let's run over a scenario where Robinson on this machine on the left is trying to access the server called covertops.xyz. You go to the next slide, yeah. So in this scenario, Robinson is requesting a service or an application from a server. So Robinson in this case would be the client, while covertops.xyz would be the server. And let's think about the model, the TCP/IP model, as different things that we have to think about when requesting an application. So first of all, what exactly are we requesting? In this case, we are requesting a web server. Can you go to the next slide? Yeah, so we are requesting a web server, or specifically HTTP, which is the protocol used for web. And this specific layer, we will call it an application layer, because that is where we define what application we are requesting. So it could be web, it could also be file sharing, it could be a database. There's a ton of different applications. But in this case, we are just focusing on web. So web would be the application we are requesting. Another thing we have to think about is what is the manner in which the data would be transmitted. So there's two different ways data can be transmitted. It could be through TCP, which is slow but reliable. TCP is the protocol that does regular checks and makes sure that all the data gets to the destination. Or we can have UDP, which is fast but unreliable. And UDP is sort of like, think about like streaming or gaming, where speed is the most important factor, and having the lowest ping. I think it's the lowest ping is key for that service. But in this case, we want TCP because for the web page, we want to make sure that all of the content is there and all the content is formatted correctly. So in this case, we are going to use TCP, slow but reliable. Another thing we have to think about is where will the request be sent? And this is kind of like a two-parter because there are two different addresses we have to think about: the IP address and the MAC address. And those are going to be in two different layers: the network layer and the data link layer. So you go to the next slide. So those two different things are going to be in two separate layers, an IP address and a MAC address. And Robin is going to talk about those a little bit more in detail, but think of it this way. So an IP address being like a house address, while a MAC address being like you and your personality and your identity and all those things. So IP addresses can change depending on what network you're in. Similarly, like you can go to a different place, move to a different place, and then you take on a new address, like a house address. But your characteristics, your personality, your identity mainly stays the same unless you like go under some identity crisis, then it's a little bit different. But generally, although like the IP address can change a lot more, the MAC address is built into your hardware. So it would be a lot more difficult to try to change that. And then last but not least, we want to figure out what medium are we going to transmit the data over. So this is where the physical layer comes into play. And we can think about it as either, transmitting voltages over a wire. So you could say like 5 volts equals a 1, while 0 volts equals a 0. And basically when you're transmitting data over a wire, it's like ones and zeros. So it could be voltages over wire or like radio frequencies if you're connected to a wireless access point. So that is what the physical layer deals with. And all of these layers have numbers associated with them. And it's important to know because when you're talking with other people that are talking about networking, they're not going to refer to devices like routers or switches. They might refer to them as layer 2 devices, layer 3 devices. So it's important to know what specific layer that they're talking about. And basically, when we say like a layer 3 device, that means something that has routing capabilities. So we can talk about a router, or there's something called a layer 3 switch. So it's very important to know the layer numbers for the model. And we went over the TCP IP model, and I think Jacob's going to go over the OSI model in a little bit. But the difference between them is that TCP IP model is a little bit shorter in that the application layer for the TCP IP model, how do I word this? So the OSI model is a little bit more complex in that there's a lot more things going on in the application layer. So TCP IP is more like a simplified version of that. Okay, I'm going to hand it back to Robinson to talk about addresses, ports, input.
All right, so the first thing I want to go over for this are addresses. And like Taylor mentioned, he kind of briefly went over IP and MAC, but I'd like to give another analogy for this. So think of, okay, so addresses are a way to uniquely identify a computer. And there are usually two addresses on a computer, one of which is MAC and the other is IP. And think of the MAC as a VIN for your car, like a VIN ID, right? So it's like when the car gets manufactured, it's going to have a VIN already on the car, and the IP is the license plate of the car. So the VIN is going to always be with the car no matter what. That stuff never changes. And the IP, the license plate, you can customize it. You can change the what your license plate says and all that. So that's how I think of it, of the difference between the two. And these two addresses are used for different things. So for MAC, it's going to be within the local area network. So if a device was communicating with another device on the network, it will use the MAC. But if it's on another network, it will use the IP to send data to the other end device. And to kind of make it simpler, think of it as like different use cases. So when you go to the car shop and get your car fixed, one of the things that they're going to take into consideration is like your VIN number, right? So they're going to write that information down, and like, you know, it uniquely identifies your vehicle. But if you get pulled over by a cop, they're going to get they're going to get your license plate. So they're like they're different use cases for different scenarios. And like Taylor mentioned, protocols are like is the manner which data is being sent, and there's two ways that are data is being sent. One is UDP and the other is TCP. UDP is connectionless, so it's a faster connection, but it's unreliable because it doesn't establish anything with the other endpoint. So if you think of like watching streams and all that, that's using UDP because it's gonna give you the fastest connection, but you're gonna experience lag, you're gonna experience buffers and all that. But for TCP, it's the opposite. It's slow, but it's reliable. So if you were to connect to a website in the browser, it's most likely going to be using TCP because you want to officially connect to the other end device so that the communication is being established and all the packets that are being sent are actually sent. And ports are a way to identify services on a computer. That's basically it. It's just a number associated with a service, and they're usually called default ports, or most common top common ports or something like that. And for port 80, it's usually associated with HTTP. So if you go on a web browser and you go to websites, you're most likely going to be using port 80. And port 22 is associated with SSH. It stands for Secure Shell, and what that is, it is a way for you to remotely connect to another machine. And for DNS, it's associated with port 53, and what it does is it translates the domain name to an IP address, so you don't really have to type in a bunch of IP addresses when you want to go to websites. So if you hit google.com, DNS takes care of it for you, and it just sends you to the website. And to like break it down, since I think ports are a bit confusing, I think of it as a logical concept. I think of it as a gigantic hotel room, and inside that hotel room, you have a bunch of doors, right? And each door has a room number, and these room numbers are the port numbers. So in room 80, you have HTTP living in it, but at the same time, it doesn't have to be HTTP. It could be any other port, any other service. So port 80 can be running SSH. It doesn't really matter, but just think of it as a logical concept to define what service is running on in like a room. So I'm gonna share my screen, my terminal real quick to kind of go over the Windows commands. Can you guys see this?
Yes.
Oh, perfect.
Is there a way that you can increase the size of the font?
All right, so the first command was, ipconfig. So in Linux, it's IPA, not ipconfig. So if you type in IPA, you see the network interfaces that I was talking about earlier. So you have the loopback interface, which is localhost 127.0.0.1. The next one is ENS 160. This could also be like ETH something, like a number. And this is the interface that is associated with a certain IP, and this IP allows you to be within a network and communicate within a network and all that. And this Docker interface is an IP for your Docker containers. The next one is netstat. So I type in netstat tac ANO. It basically it's network statistics, and the flags are going to show you open and connected ports. Oh, whoops. So you're going to see a bunch of information here. What you want to focus on is going to be right here, because then these are the active internet connections. So you see here, like on the local host, like I explained earlier, you see DNS, you see a super high port number, but you also see SSH as well. And this 0.0.0.0 means it's listening on the entire network. So anybody can connect to port 22 to this machine on port 22 to SSH in, but the rest of these 127s are localhost only. So they're within the computer itself, and it's not just like an open port. Do you want me to go over the Linux ones?
Yeah, you can go over netstat toolbit and ss peanut. Those are
that.
basically similar, but I think it's good.
Netstat Tulpin is similar to what I just showed you, but it's the top right here. It's just the top. So SS Peanut is socket statistics, and these flags will show you different things. It's similar to Netstat Tulpin, but it's more, I prefer it better because then it's just easier to read. So it shows you the same information about sockets, which are ports and stuff like that. So you see port 22 here, you see my computer IP, and I guess what it's connected to, and like a high port number. You also see, you basically see the same thing as Netstat Tulpin and Netstat ANO.
Yeah, SS Peanut is newer than Netstat, and if you go on any like Stack Overflow thing and ask for like any Stack question, they tell you to use SS instead. So that's just the difference. Although they have the same functionality, SS is newer.
All right, I'm gonna hand it off to our guest right here, our feature, Jacob.
Very cool. Thank you. So, hello, welcome to the packet tracer segment of this presentation. Today, I will be going over packet tracers. So the point of this segment is to give you a sort of visualization of how devices communicate. So we're going to be looking into the packets that computers send and how it goes across the network, kind of like the life of a packet, but at a more like high level overview, so you don't get too confused. But on the left-hand side, you'll see that I have the packet tracer software. On my website, I have a blog on how to download packet tracer, or you could just Google it. It doesn't matter. But on the right-hand side, I have what I'm going to be going over, such as explanation of topology, explanation of ping, and etc. So topology. So topology is just a fancy word for network diagram, right? So why do we need a network diagram? So we can see the different elements of the network. So, oh wait, just to confirm, everyone can see my screen, right? Or
yeah.
Okay, cool. So elements of a topology would be like the server over here, or this PC. So I named this one Robinson, I named this one Dylan Tran, and this one Taylor, and also the ports. So this is great because you get an overview of the network, right? So that's what a topology is. It's just the collection of your devices where you can see them all. But yeah, so I'm going to be going over ping. Ping also stands for internet. It's used to test network connectivity. It's also named packet internet or internetwork groper. I've never used those terms before, but just know it's used to test network connectivity. So the way it works, it uses ICMP echo requests. So there are two types of ICMP. So ICMP is just a protocol that ping uses to verify connectivity. There's two types. There's 0 and 8. Type 0 is the reply, and type 8 is the request. So when you think about ping, it's basically asking if the other device is alive or not. So the command over here where I'm going to use for command prompt is ping and then the destination IP address. So say Robinson has this massive crush on Taylor, right? So he wants to make sure he can connect to Taylor. So he's going to use the ping command, right? So he's going to do a ping and a destination address of Taylor's IP address. So ping 192.168.0.3. And where these protocols come in, he's going to send an ICMP type 8 because that's a request. He's requesting information of whether or not Taylor is actually alive, right? And once Taylor receives it, he's going to reply with ICMP type 0, right? Because he's replying to the request that Robinson asked for, right? So I'll do a quick example of how to ping. So, Robinson first. So I'm going to open Robinson. I go to command prompt. So this is the equivalent of you just going to CMD over here. But if you ping and then the destination IP address, so 192.168.0.3, which is Taylor, you can see that we get a reply, meaning that they can actually communicate with each other. So how do we use Packet Tracer to get like a deep dive into ping? So what we're going to do, we're going to go on the right-hand lower corner of the Packet Tracer software. We're going to click on simulation and it brings up the simulation panel. So this is where you're going to be able to control the simulation. So you can see what kind of protocols are being sent across the network, or basically the activity of what's happening on the network. So at first, you're going to see a bunch of filters on here. You can delete all of them by doing show all / none. And then as you can see, it changes to none. And then I can select ICMP to only look at the ping traffic between the two devices. So I'm going to exit out of this. And since we're on, let me discuss some of this stuff in the simulation panel. So here's the title, right? And here's the event list. So this is going to be the activity on the network. It's going to be capturing that and putting it on the event list. So you can see them in order and you can actually roll back to where the packets are. So constant delay, reset simulation, those are pretty useful. The toggle over here is the speed at which the packet travels. So when I say packet, I mean the data that's actually being sent. So when Robinson sends data, or when he's pinging, he's sending data to Taylor. So that's kind of how we control that in the simulation panel. But you can also skip. You can do an autoplay over here. But yeah, and then I already went over the filters. So if I were to start a ping again over here, it's going to capture that packet. And you can see that Robinson has this new packet called ICMP because we're trying to verify connectivity with Taylor. You can actually click on that envelope over here and see more information about that. So Taylor, I believe, talked about OSI model and how it's different. So OSI model just has more layers and it's more sophisticated, if you will. It goes more into how devices communicate. But since we're only learning about ping, we only have to worry about layers 1 through 3 because ping only goes up to layer 3. So here you can see that we have the source IP address and we have the destination IP address. So the source IP address is Robinson, right? Because we're the one that wants to verify connectivity. And once it reaches Taylor, we want Taylor to know how to get back to us, which is why we use the source IP. And then destination IP is so we know it's the person we want to verify connectivity with, right? So that would be Taylor because we did ping and then the destination IP address. And then here's the ICMP message type 8. So type 8 would be the request, right? Because you want to verify connectivity with Taylor. So once Taylor receives it, he's going to notice that it's type 8 and he's going to reply to that request. And then we have layer 2. We just have the MAC addresses. I very conveniently put the MAC addresses next to the computers. You're welcome. But as you can see, the source MAC address is Robinson and the destination MAC address is Taylor. So if we were to go forward in time to see where, I forgot to discuss something. So there's two types here. As you can see, we have in layers and out layers. In layers is the data that you're actually receiving from the computer, and the out layers is what you're actually sending you're sending out your ports. So for example, layer 1 over here is where Robinson is going to send his data out of. So FA0, which is just this port over here. But later you'll see more in layers and how it changes to the out layers, which is actually pretty useful. But yeah, so go here and then we click next. You can see that Robinson sends it out of FA0 to the switch. And so I'm not sure if we discussed this earlier, but the switch, whenever you hear a switch, always think layer 2. And then layer 2 is just MAC addresses. So the switch is only going to deal with the MAC address at this point. So That's what switches are for. So we can connect these end devices and they can communicate with each other. So I can actually click on this envelope. You can see we have more source MAC addresses. There's no layer 3, right? Because it's a switch. The switch isn't smart enough to look at the IP address because it's only connecting the multiple end devices together. So you can see the source and destination MAC address have not changed. It's the exact same, Robinson to Taylor. And what the switch is going to do, it's going to look at its MAC address table, and it's going to try mapping that destination MAC address to the port that it last saw it on. So I know it's a little confusing, but if this is your first time hearing it, but it's basically looking at its table and looking at where it can send it, where the actual host is. So as you can see, it's still the same MAC address over here. And then there's a lot of messages in chat. Hopefully y'all are answering them, but yeah. So if I send it again, it goes to Taylor because the switch knows that this MAC address over here comes out of this port. It's just built different, but yeah. So when we open Taylor's, we can see more information at layer 3 because it's just a ping request, right? So the in layer again is the receiving end. So this is what it's actually going to look at. So it's going to look at, oh, okay, so 192.168.0.4, or in other words, Robinson sent me this because this is my IP address. So I should probably take a look at it, right? So this is an ICMP message type 8. So it realizes that it's a request. And then it also sees the destination MAC address, so it can put that as well. And then the port at which Robinson sent it out as. So now it's going to create a new packet replying to Robinson. So that's why there's a type 0 over here. And then the MAC addresses as well, except the destination MAC address is that of Robinson's and the source is that of Taylor's because he's replying to it, right? So now it goes back to Robinson with the request. And as you can see, we get a reply. That means the ping was successful. So that's how ping works. Hopefully, maybe I have this packet tracer on my website, so you can go and download it if you want. So if I put it back in real time, you can see the ping works. And if I also ping the server hosting swift.com, hopefully it works. Yeah, it works. So that means I can access the website on there. So I can go www.swift.com and then I can access the website. So that's why pinging is very important. It's to verify connectivity. But yeah, if you want to play around with this, it's on my website. I think I put a drive to the I put a link to the Google Drive for you to download it. But yeah, that is pretty much it for me.
All right, thank you, Jacob. That was a pretty awesome Cisco packet tracer demo. Pretty sure everyone's super excited to listen to packet tracer. I know I am. Okay, next we'll go over Wireshark and TCP. So I'm gonna share my screen and I'm gonna open up Wireshark. So I hope you can all see this now, right? All right, cool. I'm gonna just, okay, yeah, so this is Wireshark. Wireshark is a packet sniffing tool. And what that means is that with an application like this, you can capture all the packets that go over the network or go into your computer. So this is very useful when you want to go to like a Starbucks and or like an airport and look at whatever everyone else is doing. Don't do that. But it's good for troubleshooting. I think packet sniffers are really good to try to troubleshoot any networking issues. So once you open up Wireshark for the first time, you should have a screen that looks like this. And you're gonna have a bunch of interfaces on the bottom here. And these are gonna be all the different interfaces that you can sniff traffic from. So the one that I'm using right now is 0. So I'm just gonna double click it and just let it run. So there's a lot of UDP packets going on. I think that might be correlated with Zoom. But yeah, there's a bunch of stuff that's going on here. So I'm gonna stop because it's like so much. But yeah, this probably looks like Zoom data because it's going through UDP and for like Zoom, which is like a streaming conference kind of platform. But it's most likely going to use UDP. So if you go into Wireshark and kind of look at the data over here, they're similar to like the OSI model or the TCP/IP model. You can look at the different elements of each packet and go through these drop-down menus to look at the different details. So this is everything that goes into like connection or like any packet that travels over the network. You have to think about things like interface IDs, what encapsulation type you're using. This is basically for layer 0 or layer 1, I think. And for layer 2, which is like talking about MAC addresses, I'm on a Mac. So it's going to give me some Apple MAC address. By the way, when you look at a MAC address, the first 3, I don't even know what these are called. The first 3 parts of it are, I think it's the vendor of the MAC address. So you can like look at a MAC address and do like a reverse search to see like what brand your NIC is. And I think I'm on Apple, so this is going to show Apple. And then the last 3 parts of it is unique for every NIC that you have. If you go into here, this is talking about layer 3 stuff. So you can see like the IP address I have and like destination. And there's more things like talking about what UDP ports I'm using. So my source port is 50433 and my destination port is 8801. And the data that's actually being sent is sent like this, and we don't really know what what it means, but we can infer that it has to do something with either streaming or gaming or something like that. Yeah, so if you open up Wireshark for the first time and you don't do any edits, your interface might look different. And the way that I'm able to get these fields to show the source port and destination port is just by right-clicking the columns or the column headers, and I can go into column preferences. And this is basically showing what columns I have. So I have time on the very left and times on the top over here. If you go down, I have S port and D port, which stands for source port and destination port. By default, Wireshark doesn't come with this. So it's very important to go into column preferences and sort of change what you want to put on there, because some of the information is useful, some of the information is very useless. And I think having a source port destination port is super useful when looking at packets. So this is a little bit about Wireshark. Anyone have any questions about Wireshark? Okay, I'm gonna go into TCP dump now. So share my screen. I'm going to my terminal. Minimize Wireshark. Right, increase it a little bit. All right, so this is my terminal. I'm using Tmux. Tmux is pretty cool. So TCP dump is very similar to Wireshark in that it does packet sniffing. The only difference is that Wireshark is more of a GUI-based thing, while TCP dump is more only for the command line. So you can just run TCP dump. I'm going to do TCP dump, put in my password. And basically, it's going to listen for everything. And I don't know why it's not showing everything, but let's see. And I haven't tried this yet. So I'm just going to ping 1111 to see if I get anything. Okay, I'm not getting anything. So maybe there's a setting where I have to go into TCP dump to, I don't get this. All right, I'll just make a new thing. So if you want to do a TCP dump on a specific interface, I'm gonna do a ifconfig, and I have a lot of interfaces. So I'm gonna select N0 because that's what I'm using currently. So I'll do TCP dump. I check I for a specific interface. I'm gonna do N0. Do my password again. All right, I have no idea what's going on. I think, okay, I guess I captured one packet throughout the thing for the last pane. Let me see if I can ping. I'll try ping method, ping command. All right, maybe edge roam blocks a TCP dump, but basically, if this were to work, you can specify a specific interface to capture packets from. So similar to Wireshark, where you select an interface in the beginning, for TCP dump, you can select a specific interface by doing the tech I, and then the interface that you want. You could also do specific reports that you want to filter out, and to do that, you would have to just put port, and if you want to just look at port 443 traffic, it's 443, or you could do 8801, which I have over here. It's going to be basically capturing packets that have anything to do with a port of 8801. Yeah, but most of the time, in order to do any troubleshooting things, I would go into sudo TCP dump and I specify the interface, and that's basically it. And then in order to like verify connection, I would do things like pings. Actually, let me try this. I'm gonna do an ifconfig again, and I want to see if I could use my loopback interface. So loopback interface is like a localhost interface. And basically it's only your computer that can connect to it. And it's used to verify that your networking is working. So I'm gonna try this. Sudo TCP dump tech I, my loopback interface is LO0. So if I go into my other tab and I ping localhost, okay, so now I'm getting things. So I ping localhost on this pane or window, I'm not sure what the terminology is, and I'm getting all the traffic being logged here. So one thing I can do, and this is something that you might do if you do ever use TCP dump, is you're looking at the domain names, and it could be a little bit confusing. And what if you want to look at the specific IP address associated with this name? So you could do the tech-end command to get rid of that. So tech-end means no domain resolution. So I'm gonna ping again, and this time it's going to show a 127 instead of a local host. They mean the same thing, but I'm just displaying it as numbers instead of a name. So in short, you can do TCP dump. This is regular TCP dump. You can specify an interface, and you can also get rid of domain name resolution by putting a tech end in the beginning. Loopback uses the IP range 127.0.0.1 to 127 blah blah blah. I think so. All I know is that if it begins with 127, then it's loopback, which is really confusing because there's like a private IP range of 172, and you just like flip the two numbers, and it's really different. So that's something important to know. 127 stands for a loopback interface, but 172 is something else. But yeah, TCP dump is a pretty powerful tool. You could look at cheat sheets for it. I actually use some cheat sheets for this specific demo. It's a little bit more confusing to use because it is like more terminal based, but once you get the hang of it, it's super powerful to troubleshoot any networking issues that you have. Yeah, so that's about it for the presentation. Actually, there's like one more part, but that's like review. Robinson, you want to share your screen again?
Yes.
All right. Yeah, so so to recap, networking is basically a set of computers sharing resources. And there's a lot of different important terminology you need to know. Devices such as switches, routers, firewalls, and some of the language used for networking, which is like nodes, endpoints, gateways, and interfaces. Those are really important to know. understand if you want to go more into networking. Here's the TCP/IP model. Again, each layer has a specific number. So when we talk about layer 3 devices or layer 2 devices, those are going to be devices that work with IP addresses or work with MAC addresses. So respectively, routers would be a layer 3 device, switches would be a layer 2 device. For addresses, ports, and addresses, protocols, and ports, addresses are basically logical locations of computers, whether they're logical or physical, and that would be IP addresses and MAC addresses. Ports are numbers associated with services, and protocols are the manner in which data is transmitted. So TCP being connection oriented and UDP being connectionless. And some of the tools used for networking include Cisco Packet Tracer, which is a network emulation tool with Cisco devices portrayed by Jacob, and then Wireshark and TCP dump, which are both packet sniffers, which are very good to look at the traffic being sent over a network. I'll tell you Huang put a good TCP dump cheat sheet. But yeah, that is about it for the networking presentation. So does anyone have any questions? All right, I think we're good now. You want to stop the recording, Robinson?
Yeah.
All right.